Hi everybody, it's Mrs. Dinkelman again, and we're here doing in Unit 7 integration by partial fractions. And you might not have heard of that before, that's okay. I'm just going to kind of give a quick overview of where we would use it even if it wasn't calculus. So back to algebra, I have this little example here about what we would do if we were trying to simplify. So let's kind of go through that because this is going to help us set up what it is we're trying to do here. So if you remember with these, what we had to try to do is find a common denominator. So to me, the common denominator is just going to be those two factors kind of mixed together, multiplied together, I should say. So x minus 1 and x plus 2. So that means on this first fraction, I'm going to have to multiply top and bottom by what I would call a convenient 1, which is x plus 2 over x plus 2, to make sure that we have the right denominator there. And then the second fraction I need to multiply by the x minus 1. We're going to have to be really careful about that subtract sign there just to be sure. So this first one, I'm going to have to multiply 2 times x plus 2. I'm just going to go ahead and do that like distribute as I write it here. So that's going to really be 2x plus 4 minus, because of that minus sign in the middle. We'll be careful about that, so I'm going to put parentheses here. If I distribute this 1, it's just going to be x minus 1. And you could probably skip a step there and just note that we have to make sure we distribute that minus sign as well. Okay, so I'm going to just do a couple more steps. So 2x plus 4 minus x plus 1. And so it looks like we're going to get an x plus 5 in the numerator. And then depending on your book, you might have had to multiply that out, but I'm just going to leave it. So now in calculus, what we want to do is we want to reverse that process. So if you look here, hopefully that's the same as what we have there. Again, it's multiplied out just like it probably would be in the back of a textbook for the answer. We want to integrate this, but we can't exactly do it right now. We can't do u substitution because the derivative of x squared plus x minus 2 would be 2x plus 1. Well, this numerator is not 2x plus 1, so I know that that is not going to be just a simple u substitution. But if I could turn it back, so if I could go back to how it was when I first started, like in my algebra class where it was split up, then we would be able to do this a little easier because these integrals would both be natural logs. So that's the process we need to learn. Again, it's called decomposition by partial fractions. And the decomposition is that pulling apart of those fractions that are written that way. So there's a couple of different cases that we need to go through. And what I would recommend as you're going through this is perhaps look at each case and then attempt to do the lesson or do the homework that is associated with those particular ones, and then so on. So like I said, just let's look at some cases and kind of see what's happening here. So first, this is just set up, and then I'll show you the algebra. So this first case with non-repeated linear factors, what I mean by that is if we factor what's going on in the denominator, they're not repeated, so there's not like an x minus 1 squared there, and they're linear, so there's no x squareds as part of the factors in the denominator. If that's the case, the setup, the decomposing, the pulling apart, is to take this capital letter A and put it on top of one of the factors, and the capital letter B and put it on top of the other. And it doesn't really matter what order they're in. You will see as we do things together, if you if you just choose it differently, then we will still end up with the same answer at the end. You'll just have to have a different A and a B. Ours will be reversed. So that would be case 1. Case 2, if there are repeated factors. So if you look at this one and it's already factored, but we have an x minus 1 squared. So this is a little bit different. I have a little explanation here on the right about why we have to treat these a little bit differently. So I have to have an a over an x minus 1 and a b over an x minus 1 squared. So that's the kind of weird part. It makes it a little different. And then I just put the c over an x plus 1. If this were to be x minus 1 cubed, we would have another factor here that would have an x minus 1 cubed as well. And this is kind of the y. If we look over here in the box here, if we think about what the common denominator would be for each of those, so let's just look at this first one. That common denominator, actually least common denominator, would just be x minus 1 times x plus 1. That would be what goes in the denominator. So that's not what we have over here with this 4x on the top. We have an x minus 1 squared. If we look at the second one, our common denominator would be x minus 1 squared and x plus 1. So this one works. That would have a similar denominator as what's going on over here with our problem with the 4x on the top. And this third one, the least common denominator, is also x minus 1 squared times x plus 1. Okay, so that would also work for this one. The problem with the third one is we didn't even give ourselves a chance of having this middle term. So if we completely leave out this a over x minus 1, we're just making ourselves deal with something potentially more complicated. It could turn out that that a is a 0. So it might work out that this was the way we were supposed to be, but just in case, we want to make sure that we include every possibility just in case, because we don't really know what the beginning looked like. Okay, and then finally, on this one, we have nonlinear factors. So we have an x here, we just put an a over that. Then we have an x squared factor, and that cannot be factored any further. And what we need to know is that the difference in degree between the numerator and denominator should only be 1. And so you'll see here that I have a bx plus c. Kind of think of this almost as our linear mx plus b kind of thing. But that's what we need to include just in case that were to happen. And if this was an x cubed, I would have to have, and I'll just write that. So let's just say we have a term that's x cubed plus 1. What would go on top of that? Well, it has to differ by only a degree. So that would, let's say, I'll start with d here, dx squared plus ex plus f. Okay, so we have to make sure that we differ only by a degree. So right here, that first one is just the setup part of the assignment. So if I scroll to that and show you what I'm talking about, this one is just the setup, no solving, just want to make sure that we have the setup correctly. So that's those problems 1 through 8. So that's what I recommend you do now and see if you have any questions. So pause the video, do those, and then you can come back to the algebra part. Okay, so now for what do we do? So back to this first case with just non-repeated linear factors, and we're decomposing. And you can see here on the steps I've already factored, so x plus 2 times x minus 1. This is the one we kind of already know the answer to, but it's nice to be able to go back and look and see that we're right. So we split it up with an a over one of the factors and a b over the other. And then our second step is we're going to just go ahead and we're going to multiply by the least common denominator. And I'm going to show you kind of in action what that does for us. So right here on this part, what's going to happen is all of these will cancel. Kind of think of cross canceling here with those. So you can see here we end up with just an x plus 5 on the left hand side. On this one, the x plus 2 will cancel with the x plus 2, but we'll still be left with this x minus 1. So here you can see we're left with a times x minus 1. And then for this next one, for the b, the x minus 1 would cancel, but we'd be left with the x plus 2. Now I'm going to give you two options. I'm going to go ahead and try them right here, and then if you want to scroll down and see what those are, that's fine. But there's really two options. So option 1, I think, is the easiest. I want to make sure that I have these in the right order. Okay, I'm actually going to do option 2 first. Option 2 to me is the easiest. This method, though, doesn't always work. Sometimes we have to do a combination of both of them, which is why I'm going to show you both. So with option 2, again, I know I'm going backwards a little bit, and I'm going to just go from here. There are two values for x right here that would make something become 0, and that would be 1 and -2, and we can see that happen in a lot of places here. So I'm going to just test and see what happens when x is 1, and then I'll also see what happens when x is -2. And what I'm going to do is just literally substitute those numbers in for both sides of this equation. So on the left-hand side here, x is 1, so 1 plus 5 is going to be 6. Right here, next to the a, that's going to be a 0, so that makes a disappear, which is really nice. I'm just going to go ahead and put a 0 here. You don't have to, but I just want you to see that I did think about it. And then on this one, when x is 1, I'm going to get b times 3, so I'm going to call that 3b. So kind of in a tricky way, I have figured out that b equals 2. Then I'm going to go in and do the same thing, but now I'm going to plug in -2. So -2 plus 5 is 3. Over here, -2 minus 1 is -3, and that's times A. And then over here, -2 plus 2 is 0 times B is 0. So again, nicely, I have now figured out that A is -1. So what I would want to do is I would want to come up here and say, all right, now I know it's -1 over x plus 2 plus 2 over x minus 1. Okay, so that's really option 2, at least in my notes here. Again, very easy, very straightforward. Sometimes it doesn't work exactly like that. So I'm going to show you one more option so that you know how to do both of those. Okay, so what I called option 1 in the notes here, again, I'm going to go straight from here, is to actually simplify what's going on here on both left and right side. Left is really already simplified, so I'm just going to call that x plus 5. And then I'm going to go ahead and distribute the a, so ax minus a, and distribute the b, so bx plus 2b. Now, it's a little bit tricky when you do this one, and it's a little bit different than you've solved before. So what I want you to notice is on the left-hand side, there's one x. We have to think like terms here because only x's can give us x's. So on this side, there's an ax and a bx. So those things have to be equal because that's what our equal sign means. So that really tells us that a plus b has to equal 1. Okay, those coefficients have to add up to 1 for our x terms. So now let's look at just the constants. So that 5, again, think like terms here. The only thing that's going to allow us to equal up to a 5 is going to be -a and 2b. Okay, so now our job is to solve, and this looks a lot like a system of equations here. So I'm just going to take these two that I created, and it's actually kind of set up really nicely for elimination. If I add both of these together, 1 plus 5 is 6, a and minus a is 0, and then b plus 2b is 3b. Hopefully this looks really familiar because we got that already doing a different method. So there's b is 2. And then what I would do, again, back in algebra class, is I would come up to a really simple equation and say, okay, if b is 2, then a has to be -1 because, oh, I need those to add up to 1. Okay, so there's really two options there. For a while, you can kind of decide what you want to do there, but I'm going to show you an example where you kind of have to do a little bit of both. Okay, so I kind of recommend at this point, actually, I was hoping that we could do a problem where we would see a combination of both. So if you don't mind, I'm going to go ahead and do one of the homework assignment problems, and I want to see one that has a repeated factor. So I think I'm going to do perhaps number 12. So what I want to do with number 12 is instead of have that, I'm going to write it as x minus 1 squared. And then remember with repeated factors, I have to do it a little bit differently. So a over x minus 1 and b over x minus 1 squared. Next step, multiply by the least common denominator, which is just x minus 1 squared. That's the least common denominator. So everything cancels here. I'm just going to have 7 minus 3x. I'm going to have a, only one of those is going to cancel, so a times x minus 1. And with b, they're all going to cancel. So here's where the issue is. Remember, I want to pick things that are going to make 0. So I really technically only have one factor, which is x minus 1. It's just repeated. So let's go ahead and just see what happens when we plug in x equals 1. So that's going to be 7 minus 3, which is 4. That's going to become 0. And then we're just going to have b. So that's nice. But how do we get b to go away so that we can figure out what a is? So there's a couple ways, but to me, using a combination of what option 1 and option 2 are going to be. I'm going to go ahead and simplify this, write it right down here. So 7 minus 3x equals ax minus 1 plus b. So this one's actually going to be quite easy for us because if I think about what's going on with x's, I just decided to pick x's because, I don't know, I just know what's going to happen here. There's only one thing with an x over here. So this tells me that A has to be -3 because that's the only way we're going to get an X. So I'll let you kind of finish up that problem as far as putting the fraction together for your final answer. Okay, and then finally, I don't have an example here, but I'll go back up to the previous example. The last thing we want to do in calculus is we actually want to find the antiderivative. So let's go ahead and do that with one of the problems we have up here. I might have to write that in there. So let's pretend this end problem here was an integral with a little dx at the end. So now what we know is that this is how we want to integrate it. So the integral of -1 over x plus 2 over x minus 1. So when we do that, these are going to be, a lot of them are going to be natural logs, not all of them, but when there's an x to the 1 in the denominator, you know that that's going to be a natural log. Suddenly added a little b for me there. So that's going to be, there's a negative there, natural log of x plus 2, 2 natural log of x minus 1, and then don't forget your plus c. And then one more thing that I noticed as I was looking through the assignment that I should add into notes there is this evaluate the integral. So here, if the numerator of the fraction is the same degree or higher than the denominator, you will need to perform long division first. So let's just see if we can see one of those. I can see number 23 there is one that we have to do long division first because the degree of the numerator is higher than the degree of the denominator. So it might be helpful for you to remind yourself about either long division or Polydoku, either one. This might be a strange problem to do Polydoku with. We'll try it with both, just so you can see it. I'm going to go ahead and do long division first with that one, and then if you want to wait or fast forward, I will do Polydoku next. So what we do with this is we figure out what do I need to multiply that by. I don't know why that went away all of a sudden. To get 9x cubed. Well, that's going to have to be a 9x. So then we get multiply here, 9x cubed minus 9x. Remember with this line, what we do is we subtract so that those become 0. And now I'm going to have 13x plus 3. Remember what we do with that is we take that remainder. I know it's a remainder because now we're less than the degree, and we put that over the divisor for our denominator. This is the part now on number 23 that you need to do partial fractions for. Just don't forget that you have a 9x there. So we're going to do the integral of 9x, and then you're going to figure out what the fractions are, okay? Okay, if you want to do Polydoku, so let's do Polydoku instead. Oops, I thought I was erasing. Doesn't want to erase. There we go. Okay, Polydoku, what we do, and again, this might look a little strange, but it'll still work. So our divisor is really x squared. We should probably, let me think about this, put a 0x in there. We'll see if that works out, and a minus 1. So same thing. We have, I'm going to put that 9x cubed here in the middle. We have to figure out what to multiply by, so that's a 9x. I guess I didn't really need this. I really just need this if I have an x squared that kind of pops up. So remember what has to happen in this Polydoku is that the diagonals sort of match up. It's not liking me there. So 0x squared, that's fine. Those diagonals match up. Negative 9x, but I need really a 4x, so that's going to have to be a 13x there. And then no number here, but I have a 3 left over. So you can see here, this is going to be my remainder, same as we saw over there. Again, it might be helpful to look up Polydoku and just try a couple problems if you're struggling with that, because I know it's been a while. Okay, good luck.